Good evening, dear students.
Good evening, ma'am.
Yes. My name is Richa Patil, and I am going to deal with chemistry subject. Okay. So the first topic, as you know, in chemistry is which one? Some basic concepts of chemistry. Okay. So what all things you have discussing in this particular chapter? Yes. So what all important? So based on CET point of view, okay. So what are the important topics which are covered from this particular chapter? Okay. So here, just a second. I think. So I'll just share the synopsis here. Okay, so what we are doing in these classes? Okay, so here we are mainly going to stretch on the MCQs. Okay, we are going to see the MCQs. So after each syllabus is completed, okay, so what we are going to do? We are going to see the synopsis from that particular chapter. Okay, so yes, I'll just share. Okay. So here, so what do you mean by synopsis? Synopsis is nothing but short, uh, short notes. Okay. So what is chemistry basically? Okay. So chemistry is nothing but the surrounding. Okay. So we are surrounded by the chemical things, right? So matter is one among that. So what is matter? So first we deal with something called as matter, right? So what is matter? It is okay. It is the surrounding. Okay. So which is around us, right? So it consists of different materials. So matter is something which occupies space and has some mass, right? Simple definition of matter. So this matter you might have studied, okay, how it is classified, physical classification as well as chemical, how it is classified chemically. Okay, chemical classification is given. So physically, if we see the matter, it is of three types. Okay, solid, liquid, and gases. You know that. And if you see the chemical classification, okay, so they are classified as mixtures. Okay, pure substances. Then there is again, you might have studied about what are mixtures. Okay, so in mixtures, again, we have something called as homogeneous mixture, and there is something called as heterogeneous mixture. What do you mean by homogeneous mixture? So homogeneous mixture means, suppose I have a beaker. Okay, I have a beaker. Okay, in that means it consists of, I have taken water in that. Okay, I have taken water in that beaker and I have added sugar to that. Okay, I have added what? I have added sugar to that. So what will happen if I stir this? Okay, so what will happen? So I have a glass. I have taken water. Okay, water is present in more quantity. To that, what I have added? 1 tablespoon of, okay, 1 tablespoon of sugar. So after adding this, I'm going to mix it. Okay, I'm going to mix it well. So what you'll be able to see, the sugar will be mixed. Okay, it will be dissolved in that water solution, right? It will be dissolved in the water solution. Same way again, if I take another glass of water, okay, I take water in more amount. In that I add salt. Okay, I add 1 tablespoon of salt. Now, what will happen? Again, this will also going to dissolve. Will you be able to see two different layers? Yes, will you be able to see two different layers there?
No.
No, right. We are not able to see two different layers. So this type of mixture, it is called as what? It is called as the homogeneous mixture. Okay, it is called as homogeneous mixture. In homogeneous mixture, okay, we will not be able to see any different boundaries. Okay, we are not able to see any different boundaries. Okay, it will be one uniform solution will be formed. Same way, what is called as heterogeneous mixture? Okay, what is called as heterogeneous? Heterogeneous means what? Suppose another example I'll give you. Okay, take a glass of water. Okay, take a glass of water. In that glass of water, I add now sand. Okay, I add sand to that. What will happen to this solution? What you will be able to see here? Yes, what you will be able to see?
Layers.
Layer, right? You'll be able to see a layer. Okay, sand will get settled down at the bottom. Okay, sand will settle down at the bottom and your water will be above that. So you'll be able to see two distinct layers. Okay, two different boundaries you are able to see. Okay, one water separately and sand separately. So this type of solution in which you can see boundary, okay, so there is no uniformity. It is called as heterogeneous solution. So these all things you have. So these are the basic concepts. Okay, when we are entering into chemistry. Okay. So as you know in your schools, okay, you have studied physics, chemistry, biology as one subject under science. Okay. Now when you have entered into PU1, okay, so how you are going to study here? You are going to study all the three subjects separately. So physics separately, okay, you have physics textbook separately, chemistry textbook separately, biology separately, and all the papers, okay, physics you're going to write for 100 marks, chemistry 100 marks, and biology 100 marks, okay. In your school, you might have written for science together for 100 marks, but here we are going to, okay, we are going to study in depth, right? So these are some of the basics of chemistry. Okay. So so
Ma'am,
here, then again, next is substances. So here, okay, so what are the important concepts which we have to focus on? Okay, so Dalton's atomic theory is there. Then you're going to study the different laws of combination, chemical composition. So these are all theoretical. Okay, so that will not see in detail. That is then what are the different laws? That is law of multiple proportions, law of reciprocal proportion. Okay, Gay-Lussac's law. So these are the different laws, Avogadro's law. So these are the different laws. Okay. Then the physical, okay, the SI units. Okay, how we write the SI units. Then atomic mass, okay, molecular mass. So important, okay, what is the important on what type of questions we are going to solve? So important is atomic mass. Okay, atomic mass is what? It is the average, okay, average or relative mass of any atom of the element. Okay, so it is compared when we are comparing the atomic mass of any element, it is compared to 1/12th mass of carbon 12 isotope. Okay. So to what it is compared? It is compared to 1/12th, okay, mass of carbon 12 atom. Okay. So this is nothing but 1 AMU. That is one atomic mass unit. Okay. One atomic mass unit is what? It is 1/12 the mass of carbon 12 atom isotope. Okay. So how we are going to calculate the average atomic mass? Average atomic mass. Okay. We are, so based on this also, we are going to solve the problems on average atomic mass. Okay. Just a second. Yes, now we will be able to see. So, okay, now you'll be able to see this. Okay. So now here you can see, right? Okay. So these are the important concepts. So SI units. So go through the SI units. Okay. You might have studied in your theory class. So just I'm going to revise it. So how is length given? Length is given as meter. Okay. It is given as the symbol is given as M. Okay. Then mass, it the unit is kilogram. the unit symbol is kilogram, that is kg. Okay, it is given as kg. Then time, it is the unit is seconds. Okay, so what is the unit symbol? The uh, unit symbol is what? The unit symbol is, okay, unit symbol of second is what? Small s. Okay, then temperature. Okay, next is temperature. Temperature, it is expressed as Kelvin. Okay, the standard, this is Kelvin. So the unit for Kelvin is capital K. Okay, capital K. Then next is amount of substance. Whenever we are calculating amount of substance, it is given as mole. Okay, we are calculating in terms of mole. The unit symbol for mole is MOL. Okay, that is small MOL. Then electrical current, when we are calculating electric current, the unit is ampere. Okay, AMPERE, ampere. The unit symbol for ampere is capital A. Okay, capital A. Then luminous intensity. Okay, luminous intensity. The luminous intensity can be calculated as candela. Okay, so these are the 7 basic units. Very important. You have to know this. Very important. Mark this as important. Okay, so all these units. So how luminous intensity is calculated as candela. Okay, the unit symbol is CD. Okay, small CD. Then plane angle. So these two are not so important. Okay, plane angle. The unit is radian, RAD. Okay, and solid angle, it is given as steradian. Okay, that is SR. So these are the two other fundamental quantities with dimensional units. So these two are not so important. But first 7 units. Okay, 1, 2, 3, 4, 5, 6, and 7. So please remember the units and the unit symbol. Okay, very important. Fine. Okay. Next, after the basic units, next is atomic mass. Okay, what we were discussing just now about atomic mass. So atomic mass, how it is calculated? Okay, so average atomic mass can be calculated as summation of Fi into Ai. Okay, so we are going to solve the problems based on that. So we will see. Okay, so when suppose I have okay, if I give an example on atomic mass, suppose I have iron. Okay, iron 54 and iron 56. Okay, so these are the isotopes of iron. What do you mean by isotopes, students? Isotopes means what? Isotopes means the element, okay, will have same atomic number, but the mass number will be different. Okay, such a element, they are called as isotopes. Now here, iron, okay, you can see, so it is having same atomic number, but the mass number is different. One is 54, one 56. Iron 54, it is available in 10%. Okay, the amount of iron available, okay, that is Fe 54 available is 10%, and amount of iron 56 available is 80%. Okay, so how to find the average atomic mass? So average atomic mass can be calculated as 10% means what? 10 by 100. Okay, and 80% means 80 by 100. Okay, so what we are going to do? We are going to take the atomic mass. So 54 into 10 plus 56 into how much it is? 80 divided by 100. So this is the average. Okay, this is the average atomic mass which we are going to get of our iron. Understood? So like this, we are going to solve the problem. So please remember this. If suppose in some of the cases, okay, they will ask you to find the molecular formula. So that time we are going to use this formula, that is valency is equals to atomic weight upon equivalent weight, and atomic weight is nothing but equivalent weight into valency. So these two also please mark this. Okay, please note down these formulas. So using these formulas only, we are going to solve the problems. Okay. Next concept is molecular mass. Next concept is what? Molecular mass. So molecular mass. Okay. So molecular mass. What is molecular mass? It is the sum of atomic masses of the elements present in a molecule. Means what now? Suppose I have CH4. Okay, what is CH4, students? It is methane. Okay, it is methane. Okay, so methane. So how do you find the molecular mass? What is the molecular mass? What is the atomic mass of carbon? It is 12. How many number of carbon are there? Only one. So multiply by 1 plus. Okay. What is the atomic mass of hydrogen? 1. How many number of hydrogens are there? 4. So this is the molecular mass. So 12 ones are 12 plus 4. So it is how much? 16. Okay, so 16 is the molecular mass of your methane. Same way with respect to water. Okay, with respect to water, how it is? Water, hydrogen are two hydrogens. Okay, and each hydrogen, how many, what is the atomic mass? 1 plus. What is the atomic mass of oxygen? 16. How many they are? 1. Okay, so it is 2 ones are plus 16 is equals to 18 grams. So 18 grams is the molecular mass. So like that, we are going to calculate the molecular mass of the different this what elements present in the molecule. Okay, so these were two examples which I have taken of molecules. Next important, very, very important concept is mole concept. So mark this as very, very important, mole concept. So mole concept is very, very important. So based on mole concept, sure questions will come. Okay. So sure questions will be coming from the mole concept. So let us see mole concept. So what is a mole? A mole is the amount of substance that contains as many particles or entities as there are atoms in exactly 12 grams of carbon 12 isotope. So what is 1 mole? 1 mole is nothing but it is equal to Avogadro's number. Okay, Avogadro's number. What is Avogadro's number? 6.023 into 10 raised to 23 atoms per mole. Okay, so this is what? This is the Avogadro's number. Okay, what is a mole? Very important. There can be question. What is a mole? Okay, so a mole is the amount of substance that contains as many particles or the number of atoms, okay, which is exactly equal to 12 grams of C12 isotope. Okay, fine. So if you want to calculate the number of moles of a substance, okay, if you are calculating the number of moles of a substance, then the mole can be calculated as mass of the substance upon mass of 1 mole of the substance. So please mark, you note down these four important formulas. Okay, please note down these four important formulas. So what is a mole? A mole is the amount of substance that contains as many particles or entities. There are atoms, there are in atoms exactly 12 grams of carbon 12 isotope. Okay, so what is Avogadro's number? It is 6.023 or 22 into 10 raised to 23 atoms per mole. Okay, so this was the first formula. Second formula, what is 1 mole of atom? 1 mole of atom is equal to gram atomic mass. Okay, that is 6.022 into 10 raised to 23 atom. So don't worry, based, okay, just note down the formulas. Further, we are going to solve the problems. So we will use this important formulas there. Okay. Next, what is a mole of molecules? The mole of molecules is equals to gram molecular mass. Okay, which is equal to 20. If you are calculating the number of mass in volume, then we are going to take the standard temperature pressure, okay, at STP, at standard temperature pressure condition, which is equals to 22.4 liters at STP. Okay, so these are all the important formulas of your mole concept. Okay, so now based on this, let us solve the problems. Okay, remaining things we will see later. Okay, how and when the questions will come, let us see that time. Okay, so let us go to some of the questions now. Okay, so let us start. So this is the first question. Okay, first question is what? Can you see the screen? Yes. Okay. So for the reaction, okay, Fe2O3 plus 3CO. Okay, Fe2O3 plus 3CO giving you 2Fe plus 3CO2. The volume of carbon monoxide required to reduce 1 mole of ferric oxide is. Okay. So how, so what they have asked, let us write, first step is what? Let us write the this what? Let us write the equation. First, let us write the equation. So what is the equation? Fe2O3 plus 3CO giving you 2Fe plus 3CO2. Okay. So what they have asked for this reaction, how many volume of carbon monoxide is required to reduce 1 mole of ferric oxide? Which is ferric oxide? This is ferric oxide. Okay. So how many moles are required here, students? So here 1 mole of for 1 mole of this, how many moles are required? 3 moles, right? You can see 3 moles of carbon monoxide are required. 3 volume. Okay.
US Canada.
Okay. So here 1 mole plus how many this is required for 1 mole of ferric oxide? 3 moles of carbon monoxide is required. Okay. Now, so what we are going to do, we know at standard temperature pressure, we are going to multiply it by 22.4 liters at STP. Okay, we have seen this. So how many moles? 3 moles. So 3 moles into how much? 3 moles into 22.4 liters. So how much it is? Just see what answer you are going to get, students. Just see what answer you are going to get. So for 1 mole of Fe2O3, it requires 3 moles of carbon monoxide, right? Therefore, so how much it is? So for 1 mole, it requires 3. So 3 into 22 at standard temperature pressure. Okay, the
6.2.
67.
7.2.
Yes, option number A. Okay, so 67.2 dm cube. Dm cube is nothing but liter. Okay, we can express it as 1 liter or 1 dm cube. Okay, so this is the units we write for volume. Okay, whenever we are calculating volume of solution, so we write it in dm cube. So how much it is? So for in the this only you can see, right, in the equation only. So for one so to reduce 1 mole of ferric oxide, how many volume of carbon monoxide is required? So how many required? 3, right? So what we are going to do, this 3, we are calculating the volume, okay, for mole concept. So what we are going to do, at standard temperature pressure, we know that the volume, it is expressed in at standard temperature pressure, we have to multiply it by 22.4 liters. So 3 into 22.4 liters is nothing but 67.2 dm cube. So option number 1 is the answer. Okay, option number 1 is the answer. Okay, let us go for the next one. 10 cm cube. Okay, 10 cm cube. 10 cm cube of 0.1 normal monobasic acid requires 15 cm cube of sodium hydroxide solution whose normality is. So these are the 4 options. Okay. So how we are going to calculate this particular question? Okay. Do you know what is normality, students? Do you know what is normality? Anybody knows what is normality? Did you study something called as normality?
No, ma'am.
Okay. So what is normality? Normality is what? So did you hear anything, something molarity, molality? I think this will be at the end of the session.
Yes, ma'am.
Yes. Okay. So, this is at the last. So let me explain you about the normality. Okay. So normality is nothing but, so I'll write the formula. Just a second. So when we are expressing the normality, we are going to express the normality for one. Did you start with the practicals in your college?
No, ma'am.
Okay. So the first what we are going to do in the practicals also, we are going to find the normality only. Okay. We are going to find the, their molarity is used, but we can express normality and molarity. It is same. Only thing in molarity, normality, we are calculating the gram equivalent weight. Okay. We are taking the gram equivalent of solute. Okay. And that is dissolved in volume of solution is taken in liter. Okay. Suppose I want to prepare 0.1 normal NaOH solution. Okay. Now NaOH solution, what is the, this, it is 23 grams. Okay. So it is, sodium is 23, oxygen is 16, plus hydrogen is 1. So how much it is? 6, 7, 8, 9, 10. So 40. So 40 grams. Okay. So sodium hydroxide, what is the gram equivalent weight of sodium hydroxide? It is 40. So if
40.
I want to prepare 0.1 normal solution of NaOH, then how much amount of, okay, so I have to take 1000 ml. Okay, 1000 ml solution is nothing but 1 liter solution. So if I add 40 grams, okay, it will become, if I add 40 grams in 1000 ml, okay, so how much it will become? 4 by 100 is how much? Just see.
0.04.
0.04. Okay. So 4 by 100 is 0.04. Now same way. So we have to do like that. So if I dissolve 40 grams in 1000 ml, I am going to get 0.04. So if I want a 0.1 in 1000 ml, how much I have to add? Like that. Okay. So like this, we are going to calculate the normality, okay, of solution. So same way here also they have given same thing. Okay. So for 10, okay, we were, so this is the formula of normality. So remember what is normality? Normality is the gram equivalent of solute dissolved in, okay, 1000 liter of solution. Okay. We are considering the molar concentration. Okay. We are considering the, so it is always taken as equivalent weight upon the volume of solution in liter. So based on this, let us see. So I've just given you a brief idea about that. So now whenever we are, now here how, which solutions are there? One acid is there, one base is there. Okay. So in your practicals, okay, the you'll be having titration, something called as titration. So in titration, what we are going to do? Do you know acid, when it reacts with base, what it gives you? When
Salt
acid, salt
and
and
water.
water. Yes, very good. Okay. So when acid and base reacts, it gives you salt and water. Okay. So here in your practicals, okay, in your lab, you are going to do titration. Okay. One acid will be there. Okay. The acid is none other than HCl, and the base which will be, it will be NaOH. Okay. So what we are, what you are going to do? Okay, your concentration of NaOH will be known. Okay, this is called as the standard solution. Standard solution is that solution whose concentration is known. Concentration means what? Okay, this is 0.1 normal. Okay, what is its concentration? We know. So that is called as standard solution. Standard solution means which concentration is known. Okay, so NaOH, it is having a standard, so it will have, okay, so this much grams of solution, just now we saw, no? So if I dissolve, suppose 4 grams in 1000 ml, okay, so what I'm going to get? I'm going to get some percent of that solution. Okay, now if I want to make tea, okay, for one person, I'm going to add 2 tablespoons sugar and 1 tablespoon tea powder. Okay, if I want to prepare tea, Okay, can I put 10 tablespoon of sugar and 1 tablespoon of tea for one person? No. What will
No,
happen to
ma'am.
the what will happen to the concentration? Concentration will become more, right? It will become more. So same way, when I want to prepare 0.1%, so some amount of NaOH should be mixed in that 1000 ml of solution. So that will give you a standard solution. What do you mean by standard solution? Whose concentration is known. Okay, remember that. So standard solutions are those solutions whose concentration is known. So when we are doing acid-base titration, so what we are going to do, one of the solution will be a known solution. Known solution means what? Its concentration is known to us. We know, okay, base is present in 0.1 normal, okay. And one solution will be unknown solution. Unknown solution means what? I don't know the concentration. So what I'm going to do, I'm going to react this two. Okay, I'm going to react this two by using the titration method, and I'm going to find out the concentration of this acid. I'm going to find. So what is that formula which we are going to use? The formula is N1V1 is equals to N2V2. Okay, so that formula here we are going to use because we have one acid, we have one base. So N1, what is the N1? N1 is nothing but N1 is the concentration of your acid. Okay. N1 is the concentration of acid and V1 is the volume of acid taken, and N2 is the concentration of base. Okay. And V2 is the volume of base which is taken. Now let us put the values. What is the normality of acid? Yes. So 10 cm cube of 0.1 molar monobasic acid. So the normality of basic acid is how much? 0.1. And how much volume? Volume is 10. Okay, volume is 10 is equals to, what is the normality of sodium hydroxide? We have to find out. We don't know. What they've asked, whose so requires 15 cm cube of sodium hydroxide. So volume is given 15. Okay, 15 cm cube, or you can write ml. Okay, so it is same. So 15 ml of sodium hydroxide solution whose normality is. So we don't know normality. So we'll write N2. Now what we are going to do? So 0.1 into 10. So transfer this side. So this becomes 15. So is equals to N2. Find out now. Just see what answer you are going to get. So 0.1 into 10 divided by 15. Just see what normality you're going
Option
to get.
option A, ma'am. 0.066.
Yes, 0.066. Understood?
Yes.
Understood this particular question of normality?
Yes, ma'am.
Yes. So this titration, okay, titration you're going to do in the practicals. Okay, when once your practical starts, so that time you'll understand what is acid, what is base. Okay, how we are going to do titration. So what is standard solution? Okay, what is standard solution means whose concentration is known. Another solution will be unknown solution. Okay, unknown concentration. Okay, we don't know the concentration of that solution. So what we are going to do, we are going to find out the concentration of that unknown solution by titrating it against the known solution. Okay, so this is the concept behind the titration. Okay, so answer is option number A. Fine. Let us go for the next question. So these two questions, the last previous question and this question, it was asked in 2008, okay, for CET. Okay, let us go for the next question. So as I have discussed you mole, okay, mole is very important. So we are going to solve different types of problems on mole, okay, amount of substance, volume of substance, okay. So these all are the different problems which we are going to stretch on. Okay, so let us see next problem on mole. Mass of 0.1 mole of methane is, what is methane? CH4. Okay. So we are going to find the mass of 0.1 mole of methane. So what is number of moles? How is number of moles calculated, student? Number of moles is equals to mass of substance. Okay. Mass of substance upon molecular mass of substance. Okay, mass of substance upon molecular mass of substance. Now, what is the number of mole? Number of mole of this is how much? We don't know. Okay, mass of 0.1 mole. So we have to find the what is given. What all we know now? What all we know from this? We know mass of 0.1 mole. We don't know the mass. What they have asked us to find the mass of substance. So we have to calculate the mass of substance. Okay, mole is given. So it is 0.1 mole is equals to mass of substance. We'll keep it as it is because we have to calculate by this formula. Okay, and molecular mass of the substance, we know molecular mass. How we can calculate molecular mass? CH4, carbon 12 plus hydrogen 4, right? So 12, 30, 40, 15, 16. So 16 grams. So 16 grams is the molecular mass. So can we find out now? Now can we find out? Yes. So let us find just now. Okay, so what is the weight of the given substance?
Ma'am,
What will be
answer 1.6, ma'am.
answer? 1.6.
6.
Yes, very good. Yes, answer is 1.6. So what you have to do? You have to do, so your, what is
Multiply.
happening? Yes. Okay, so here it is divided. Okay, here it is divided. So what I have to do? I will transfer. When it goes on the other side, it will multiply. So 0.1 into 16 is nothing but your mass of substance. Okay, so if you find out like this, how much I got? I got 1.6 grams. So this is the weight of the given substance. Okay, mass of the given substance. Everybody got it? Yes, understanding?
Yes, ma'am.
Okay. Let us go for the next problem. So mole concept, very, very important. Okay. So next question. 80 grams of oxygen contains as many atoms as in. Okay. So 80 grams of oxygen contains as many atoms as in. So here we are going to cal again number of moles. So number of moles is what? Mass of the substance. Okay, mass of substance upon molecular mass of the substance upon molecular mass of substance. Okay, so what is the number of moles? Okay, mass of the substance is 80 grams. So 80 grams, okay, divided by what is the molecular mass of oxygen?
16.
O2. Yes, 16. Very good. Okay, 16. So how many, calculate the number of moles now? 80
5
by 6.
grams. 5 grams.
Grams, no, it is mole. Okay, number of moles. So it is 5 mole, M-O-L. Okay, the unit for mole we have seen, M-O-L, mole. Okay, so 5 mole. So we have calculated first mole. Now, we know that 1 mole contains, what it contains? 1 mole contains Avogadro number. Okay, 1 mole contains Avogadro number of atoms. Okay, now what is this Avogadro number of atoms? Avogadro's number of atom is 6.02 into 10 raised to 23 atoms. Okay, so 5 moles. So for 1 mole, it contains Avogadro number of atoms, that is 6.02 into 10 raised to 23 atoms. So for 5 mole contains how much? Okay, 5 mole contains how much? So it will be 6. So how much, right? 5 moles contains how much? So what I'm going to do? I'm going to do cross multiplication. Okay, so what it will become? 5 into 6.02 into 10 raised to 23. Okay, find out the answer.
30.1.
30.1. Okay, let me see.
Into 10 to the power of 23.
Just a second now. 5.6.02. So yes, 30.1 into 10 raised to 23. So if I transfer one this side, okay, so how much it will be? So it will becomes 3.1 into 10 raised to 23 atoms. Okay. So let us do like that. So now we have calculated for contains as many atoms as in. So this was for your oxygen. So same way we have to calculate for these all. Okay. So for 10 grams, for 5 grams of hydrogen. So in which it will be same. So if I check with all, now 10 grams means what? Again, what you have to do? 10 divided by the molecular weight of hydrogen is how much? H2.
1.
Okay, we'll take it as 1. So it becomes 10. Okay, it becomes hydrogen gas we have to take or hydrogen we have to take. Yes, 1. Okay. So it will become 10 mole again. 10 mole into, if I do 10 mole into 10 into 10, 6.02, see what will be the answer? It will be more. Okay, 10 into 6.02, 60. Okay, so
60.2.
first will be wrong. Let us see 5 grams. Okay, let us see 5 grams. So here, number of moles of hydrogen, the mass of substance is 5. So this becomes 5 mole. Okay, this becomes 5 mole, right? 5 mole. So again, 5 into 6.02. Yes. So it is option number B.
B.
B. Option number B is the correct answer. Okay. So 80 grams of oxygen contains how many atoms? It contains 3.1 into 10 raised to 23 atoms. And this is same as in 5 grams of hydrogen. Okay. If I calculate for 10 grams of hydrogen, it was coming 60. Okay. Double. If I calculate for 5 grams of hydrogen, it is coming the same. So 80 grams of oxygen contains as many atoms as in 5 grams of hydrogen. Okay. So this is the correct way. Is it clear up to here?
Yes, ma'am.
Okay. Let us go further. Excess of carbon dioxide is passed through 50 ml of 0.5 molar calcium hydroxide solution. After the completion of the reaction, the solution, fifth question, no? After the completion of the reaction, the solution was evaporated. Okay. The solution was completion of reaction. It is double, it is repeated. Just a second. Okay. So here, so after the completion of the reaction, the solution was evaporated to dryness. The solid calcium carbonate was completely neutralized with 0.1 normal hydrochloric acid. The volume of hydrochloric acid required is, okay, atomic mass of calcium is given as 40. So these are the 4 options. Okay. So let us solve this. So I'll give you. Okay, so what are the given things here? So what is the first we'll write. So excess of carbon dioxide is passed through 50 ml of 0 point normal calcium hydroxide. So let us write first the reaction. So calcium hydroxide is CaOH twice. Okay, to this calcium hydroxide, what is passed? Carbon dioxide is passed. Okay, carbon dioxide is passed. Okay, after passing carbon dioxide, what is happening? The solution was evaporated to dryness. The solid calcium carbonate was completely neutralized. So what you got? You get calcium carbonate plus water. Okay. So after you heat calcium hydroxide, what will happen? Water present in the calcium hydroxide will vaporize. Okay. It will vaporize and you will get calcium carbonate. Okay. Now put the values. Now here what all is given? So calcium hydroxide. Okay, so calculate the mass first. Let us calculate the mass of all. Okay, calcium is 40. Calcium is 40. Okay, plus oxygen is 16 plus hydrogens are 2. So how much it is?
58.
Oxygen.
58, ma'am.
Yeah, oxygens are 2, no? So we have to take 16 plus 16. Okay, 16 into 2. Oxygens are 2 here. No, oxygen is 16 into 2 plus 2. Now you see?
74.
Yes, 74 grams. Fine. So this is for 74 grams. Now calcium hydroxide, 12 plus 32. 4, 4,
44.
44 grams. Calcium carbonate, 16 into 3 plus 12 plus 40.
84, ma'am.
Calcium is 40 plus 16 plus 16 plus 16 plus 12. No, it is 100. Check again. Okay,
Yeah, ma'am.
100. Okay, it is 100. And water is 18. Okay, water is 18. 16 plus 2 is 18. So this is the amount of, so this everything is 1 mole now. This is all 1 mole. So 1 mole, 1 mole, 1 mole. This is 1 mole and 1 mole. So these are this all everything is present in 1 mole. Okay. Now here, next step, what we are going to do. So what all is given? So 50 ml of 0 point normal. So what is given? So 50 ml of 0.5 molar calcium hydroxide. Okay, it reacts with what? It reacts with excess. Excess means what? Carbon dioxide is present in more amount. Okay, excess of carbon dioxide. So number of millimoles. So number of millimoles reacted is how many? How many moles of this is reacted? 25. Okay. So number of millimoles number of millimoles of calcium hydroxide reacted is 25. Okay. So 1 mole of calcium hydroxide will give you how much? It gives you 1 mole of calcium carbonate. Okay. So number of if so here if 1 mole reacts, it will give you 1 mole. So if 25 grams react here, okay, how much it will give you? 25, right? So number of milli equivalent is nothing but weight in milli equivalent. So what we have to find out here? So the solid calcium carbonate was completely neutralized with 0.1 molar this. Okay, the volume of hydrochloric acid is. So what we are going to do now, first we'll find the number of molar equivalent. Okay, so the volume of calcium carbonate is how much? It is 50. It is 50 ml. Because if 50 ml of calcium hydroxide is reacting with this, so if 1 mole is produced here, so again here also it will be same. So it will be 50 ml only. So the volume of the amount of calcium carbonate formed will be 50 ml. Okay, volume. So volume of calcium carbonate is 50 ml. Okay, so normality, what is the normality then? It is equal to 1 molar. Okay, it is equal to 1 normal. So what is the given normality of hydrochloric acid? Hydrochloric acid normality is 0.1 normal. So again, let us find N1V1 is equals to N2V2. Okay, so hydrochloric acid and NaCO3, CaCO3. N1, what is the given for hydrochloric acid is 0.1. 0.1, what is the volume? We don't know. We have to calculate the volume of hydrochloric acid. So let us keep it as V1. What is N2? What is the calcium hydroxide? It is 1 molar, 1. And what is the volume? 50. Okay. So calculate. So V1 is equals to 1 into 50 divided by 0.1. Calculate how much you're going to get, see.
500.
Yes, you're going to get 500. So option number B. Okay.
B.
So for one normal, for 1 mole of calcium hydroxide, it is producing 1 molar of calcium carbonate. Okay. So if 25 grams of calcium hydroxide reacts, it will give you 25 grams of calcium carbonate only. Okay. So here, how much amount of calcium hydroxide is reacted? 50 ml. So it will produce 50 ml of calcium carbonate. So we got volume of calcium carbonate. So it is equal to 1 normal. Okay, because 1 mole is nothing but 1 normal. So the normality is 1 normal. And the normality of HCl is given. Okay, normality of HCl is given. So from normality of HCl, we are going to find the volume of HCl. So three things we know, one thing we don't know. So by putting this formula N1V1 is equals to N2V2, we are going to find out the volume of hydrochloric acid. Is it clear?
Yes, ma'am.
Okay, fine. So, yes. So today we have seen only 5 problems. Okay. So because we have done some synopsis. So again, in the next class, we'll be solving some more problems based on this topic. So please go through the textbook. So I hope everybody has a textbook. So please go through the textbook of first chapter. Okay, so that it will help you to understand it much better. And please, if you have any book or any last year papers, so try to solve questions again. Okay, if you have any doubts while
Ma'am,
solving, yes,
ma'am, small doubt.
yeah.
Ma'am, can homogeneous mixture can be separated?
Homogeneous mixture, if you homogeneous is what now? Now see here, I told you what? Salt and water. Okay.
Hmm. Hmm.
You only tell me. Okay. You take a glass, you take water in that, you add salt in that. Can you separate it after mixing?
No.
Then how a homogeneous mixture
Ma'am,
can be
ma'am, by
physical? Physical,
chemical method.
by chemical method we can try, but physically it cannot. Uh, it is not possible physical. Okay, physically you cannot do it, but chemically by after like putting different efforts we can do it. Okay, we can do chemically, but not physically.
Okay, ma'am.
Okay. Yes. So by this, we shall end the session here. Okay. So we'll meet in the next week. Thank you.